Okay, here's my equation, and I want to graph it eventually, but if I find some of these other points, it's going to help me out. So the first thing I need to do is find the vertex. As I find these interesting points, I'm going to put them on the graph, so then that should help me out. So the vertex in this case, we can look here and here. There's the x, there's the y for the vertex. Positive 2, positive 1. Okay. So 2, 1, vertex. Okay, what's the axis of symmetry here? X equals 2. It's an axis, so I need an equation. All right. You gotta tell me how to draw it, and that's what that's saying. Direction of the opening? Down. Okay, the vertex would be your min or max value. Is it a min value or a max value? It's a max. So it's the max at the vertex. Sometimes they will ask you what is the max value, in which case you would say max value would be 2. Other times they will ask you where does the max value occur. So if they say where, nah, my bad. This one should be a 1, right? Yeah. And where it occurs is 2. I got backwards there. All right. So where it happens is the x value of the vertex, and what that value is the y value. All right. Y-intercept. All right. Y-intercept, we let x be 0. So we have y is equal to negative 0 minus 2 squared plus 1. The inside of this becomes negative 2, but then when you square it, it becomes 4, but then I stick a negative back out in front of it. So I have negative 4 plus 1. Be very careful with all of these positive negatives, okay? It's a very easy place to mess up at. So negative 3 is where it says it's going to hit on the y-axis, so we can put a point here. Okay, x-intercepts can be found by letting y equal 0. And solving for x. All right, subtract the 1. Divide by negative 1. Square root, and you get 2 answers, right? Positive negative 1 equals x minus 2. Alright, so when I add 2 to both sides. Two plus 1, 3. 2 minus 1, 1. But I want you to notice something even more important than that in graphing these things. Is this axis of symmetry helps you out a whole lot. Because if you know the vertex and one other point, you actually know 2 other points. because it mirror images whatever is on this side has to be on the other side, the same y value, just on the other side of that axis. So since I knew, if you knew one, you know the other. So let's look at this point down here with our y-intercept. I can see that that is 2 off of the axis, right? It's 2 to the left of the axis. I can go 2 to the right of the axis, and I know there has to be a point there without doing any calculations. 5 points is what I will expect you to be able to find whenever you are graphing these. So if you do 5 points, which we've got 1, 2, 3, 4, 5, that will be good enough for a sketch for me. Okay, using our quadratic formula, definition negative b over 2a, I would get, in this case, negative 24 over 2 times negative 2, which would be negative 4. So that would be a positive 6. So the x value for the vertex, I'm going to put a little v, x with a little v subscript to mean the x value of the vertex is 6. How could I then find the y value for the vertex? Yeah, that would be a little bit harder, but you could do that. You might not know how high it went from there. What's another way? Yeah, plug 6 into my equation. So I know that the y for the vertex is negative 2 times 6 squared plus 24 times 6, I did not give you enough room, minus 73. And then please break out calculators. Did all that and I got negative 1. Does that seem like a kind of anticlimactic right there? Alright, so my vertex is actually 6, negative 1. Now once I have the vertex, I can get everything else, right? Axis of symmetry, x equals 6. Direction of opening, again I can look at this negative 2, this is opening down. So that makes this right here a max again. Y-intercept, this one's even easier. Bam, y-intercept. Because if I make x is 0, all that's left over there is that. How would I find x-intercepts here? Yeah, you already did part of the quadratic formula. You can go ahead and finish it off and do the rest of it. Okay. Is that good? Alright, let's look down at how you do these down here to find. And I'm going to do number 6 for you because I've got room. Okay. So if I'm going to write this in vertex form, I know I have y is equal to a. Do I have any clue what a is? Not yet. So I'm going to put in a. X, oh, I've got a vertex, so I can put that in there. So negative 2 squared plus 3. Any clues what I can do now? Plug the point in for x and y. All right, so 2 is equal to a. X becomes 0. Minus 2 squared plus 3. So 2 is equal to 4a, correct? Plus 3. Subtract the 3 from both sides. And a is -1/4. So now you've got everything you need, correct? For a vertex form, you needed the a value and your vertex. And when you think about it, that makes sense. This was a vertex, and this point describes how far it spread out. So I've got y is equal to -1/4 x minus 2, that quantity squared, plus 3. If I'm graphing it, it's actually easier to graph this one with this information. I find the vertex on my graph, so I go over 2, up 3, vertex. I find this point. I know there's an axis of symmetry right there, so now I can get a point over here. That was what was given to me. I was given the vertex and a point. Alright, and once, so to draw any parabola, you need 3 points. So it looks like I only gave you 2 with a vertex and a point, but if I give you vertex and 1 point, you got automatically the other one because it's a mirror image. Okay?